In this video, we'll try to understand the concept of electric circuit from the electricity. Electric circuit as well as electric potential, potential difference, and some of the things and some examples related to that. Let us try to understand what is the electric circuit. As you know very well, the electric circuit is what? When many devices are connected together in one circuit, it is called as the electric circuit of different components. Maybe like that ammeter, maybe like that voltmeter, maybe like that resistors, and all such type of when instruments are connected in one circuit, then it is called as the electric circuit. Okay. So how it is constructed as? Isn't it? Let us suppose this is what one bulb is there. This bulb is taken and this bulb is connected to what beta? Ammeter. Clear? And through this ammeter, if suppose this one is connected to what? One battery. This is what called as the battery. Clear? And through that, this is what called as the electric circuit. This one is the positive terminal, this one is the negative terminal, this is the ammeter, and somehow the voltmeter is connected across this what? Bulb, which is what it is electric circuit, and some amount of current is flowing through that. This one it is to be called as the electric circuit. Clear? It's very good. Now similarly, the next one, which is very important one, that is called the electric potential and potential difference. Dear students, this is very important to understand electric potential and potential difference. It's very good. What is electric potential and what is electric potential difference? Hope you are able to understand what does it mean the potential as well as the difference. The difference means what? Obviously, this difference is used to be taken between 2 points. Then only we get some difference. So no doubt. So what is the concept now? The concept is remaining called the electric potential. When you understand the electric potential and electric potential difference, then obviously some of the concepts will get clear in itself. So we'll focus first of all on the electric potential. Now you know very well, if suppose as you all are very much aware about that, if suppose there is one what we can say the plane surface, and on that plane surface what I have taken some amount of water. Clear? Now when you clearly observe to that water, will that water will flow to any of the end of that metal plate? It's obviously not. It will not flow because water is on the same level. Now as soon as I lower one end of the plate, so what will happen? Obviously the water will float toward the end which is lowered. That exactly it is to be called as the potential difference. Why? Actually I am telling you, this is what the example related to the electric potential and potential difference. Why it happens now? Why the water is why the water is moved towards what the concept it is to be called as the when the one side of the low end is lowered? Because there is some difference is created, and that difference is the pressure difference. It's a very simple. Clear? And due to because of that pressure difference, what happens? The water starts flowing toward the end which is lowered. So this is also similar. But to understand this electric potential and potential difference, let us do one thing. That imagine that there is one what we can say the charge. What I'm going to tell you, let us suppose there is one charge, and that charge is something which is placed at a point P. Clear? And imagine that there is one more charge, there is one another charge. Let us suppose this is one point P, and there are two positions I have taken. Let us suppose this position is called as the B, and the next position it is to be called as A. Clear? Now what I have done? There is one charge is there, and this charge has its own field, has its own potential, because we are going to consider this one is the source charge. Now I have taken one charge which is called as the test charge, which is placed at a point A. Now to bring that charge from A to B, I need not to do any work at all, because against this charge. Why? This charge has its influence up to point B only. Because beyond point B, it doesn't have any influence. So I can move anywhere without doing any work. When we can do work, if there is something opposition, if there is something present which is opposing to move from that point to that point. But from A to B, there is no charge, there is nothing, there is no influence, so that I need not to do any work to move this charge from point Q to point B. But as soon as I wanted to bring this charge from point B to point P, then obviously I need to do some work on this charge. What am I doing? I need to do some work on this charge. That's it is called as the potential difference. This is called as the potential difference. Work done to move a charge from one point to other point is called as the potential difference. What we are doing here? This is what? We are trying to move this point charge from point B towards point B or towards point P. So what we are doing? We are doing work against this charge. Where we are doing work? We are doing work on this charge. What we are doing? We are doing some work on this charge to move from point B to point A. From point B to point P. Clear? So this what exactly is to be called as the electric potential and potential difference. Getting what I am saying? Hope you understood this very clearly. So then electric potential and potential difference, it is a work done to move. What it is to be? Work done to move a unit charge from one point to another point is what it is to be called as potential difference. Simply, we can write it on the formula for the potential difference, that potential difference is equals to work divided by what? Charge. Clear? Why we are writing this potential difference as work upon charge? It's very simple, sir. Because we are doing some work on that charge to move from point 1 to point to other point. To move it from one point to other point. It's very simple. That is what it is to be called as the potential difference. Clear? And the formula from this definition, from this statement and from this concept, we can easily understand that the formula V is equal to W by Q, where W is the work and Q is what? Charge. As we know that, what is the unit now? The unit of potential difference becomes very simple. What is the unit of the work? Unit of work is what? Unit becomes what, sir? Come on, Joule. What is the SI unit of the work? Joule. So then, and the SI unit of the charge? SI unit of the charge is what? Come on, that is Coulomb. SI unit is what? Coulomb. So then, SI unit of potential difference becomes volt. That is denoted by what? Capital V. Also, it can be written as what? SI unit Coulomb. Sorry, Joule per Coulomb. Clear? So that is what there is a. Sometimes there is a questions related to that. What is 1 volt? So what is the 1 volt now? 1 volt is equals to 1 joule upon what? 1 Coulomb. What does it mean? 1 joule upon 1 Coulomb. It's very simple, sir. That when 1 joule of work is done to move a charge from one point to other point is what it is to be called as 1 volt. What it is to be called as 1 volt. So this is a very simple. मतलब क्या है, मैं बता रहा हूँ आपको कि अगर मुझे यहाँ से अगर दूसरी तरफ 1 जूल इतना वर्क करना पड़ रहा है, किसके ऊपर? 1 कूलम ऑफ चार्ज के ऊपर, ताकि वो यहाँ से वहाँ चले जाए. That is what it is to be called as 1 volt. Clear? So then this is what exactly it is to be called as the 1 volt. So what is 1 volt now? When 1 joule of work is done to move a charge, to move a point charge from one point to other point. यहाँ से मैं लिख सकता हूँ, when 1 joule of work is done to move a point charge or to move a unit charge. This is what it is to be called as the 1 volt. Is it clear? So all this is very important, it's very interesting, you know that. If you remember this concept, automatically you can remember the electric potential and potential difference. Also the example which I have given to you. Even though the cells that we are using in our batteries, they are providing us the potential. How they are providing the potential? Because there is some pressure difference. Getting what I am saying? There is some potential difference between the two terminals. That is what the reason we are getting the potential, no doubt. So the same thing is applicable here also, and that can be understood. Just to move a charge from one point to other point, we wanted to do some work, and that work is what it is to be called as the potential. Work done on a charge, it is to be called as the potential. Similarly, obviously, we want some instrument. What instrument is going to be used to measure this potential difference is what, sir? Voltmeter. Which instrument is that? Voltmeter is used to measure the potential. So this voltmeter is always connected in parallel. This word is very important. यहाँ पर आप देख रहे हो. Clear? So across this bulb, voltmeter is connected in what? Parallel. And diameter is connected in what? Series. Clear? So this is what is very important. Always connected in parallel, but where? Across the point to measure the PD. PD means what? Potential difference. It's a short form. Okay? Don't write it down, but this is what is very important. Clear? So this is what exactly electric potential and potential difference. Let us do some of the examples on that. Okay, I will read it. I will read it for you. How much work is done in moving a charge of 2 coulomb. How much work? That means we wanted to calculate the work. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference 12 volt. For what we are waiting now? Write it down. What? Given. What is given now? Very simple. Charge is given 2 coulomb. Potential difference is given. How much? 12 volt. What we want to calculate? Work. That work has to be calculated. Which formula should we use? Obviously the formula here. That V is equals to what? W by Q. Clear? So then V is equals to what? W by Q, which can be written as W is equals to what? V into Q. What is the V? 12. What is the Q? 2. What is the answer? 24 Joule. That's it. Therefore, that W is equals to 24 Joule. Clear? Very good. Similarly, the next example, which is related to this potential difference, how much work is done? Again, we wanted to calculate the work. In moving a charge of 2 coulomb from a point at 118 volt. This is how something different type of question. To a point at 128 volt, which means that there are 2 points are there. At one point the potential is what? 118, and other point the potential is what? 128. So from where to where we are taking? We are taking it from 118 to 128. Clear? So how to write it down? Please listen, this is very important one. Clear? What is given now? We know very well there are 2 potentials are there. We are bringing this charge from this point. At this point, how much is the potential? 118 volt. And at this point, how much is the potential? That is 128 volt. We are bringing it. So this one is called as the V1, and this one will call as the V2. So V2 minus V1 is the resultant potential. Clear? And charge is given. How much is the charge? That is 2 coulomb. What we wanted to calculate? Work is equals to how much? What is the formula? W is equals to VQ. But V is what now? V2 minus V1. So therefore W is equals to V2 minus V1 into what? Q. So V2 minus V1 is how much? 128 minus 118. Kitna aega? 10. 10 into what? 2. That is 10 into 2 equal to how much? 20 Joule. Is it clear? This is how it is very important, and that is the reason I am telling you that electric potential and potential difference is what? It's very simple. Okay? That's